Hello, everybody out there. Good morning and welcome back. Let's continue on. This is going to be the last in the 5-part series for pharmacy math. And of course, there's more types of problems out there. As you go through the course, I'll introduce new topics and new ways to do the math as you go. So watch out for those videos coming up shortly. But for today, we got pediatric dosing and AWP pricing, or average wholesale price. So you guys made it this far. Congratulations. We're almost there. All right, pediatric dosing. We got Freuds Rule. So usually most drugs are going to be tested clinically in adults. So the dosage strengths are established for adults. And to estimate for an infant in this case, using Freuds Rule, we'll use the following equation. We'll take their age in months, or closest age in months, divided by 150, and then you multiply that by the normal adult dose. That'll be the infant's dose. So infants for us, anywhere from 1 month to 1 year of age. Of course, if you're in your first month, you are a neonate. So for this example, what is the dose for a 6-month-old infant if the standard adult dose is 500 milligrams? All we have to do is put 6 months over 150 and multiply by the adult dose. So we'll round this to the nearest milligram. So for a 6-month-old baby, they'll only get about 20 milligrams, as opposed to an adult, which will get 500 milligrams. Next question, or next problem for Freuds Rule. Now we have a 9-month-old baby, and the adult dose is 1 gram. So we'll put 9 over 150, and since we want the answers in milligrams, you'll need to change your answer at the end. So here we got 0.06 grams, which converts to 60 milligrams. Okay, so let's say today was April 10th, 2018. This infant was born July 15th, 2017. So we're going to give them the age, their nearest month. So let's see, we got July to August, September, October, November, December, January, February, March, April. So I counted about 9 months. And let's take a look. We'll need to then multiply by the adult dose. And then we'll need to multiply by the supply. Because here in this question, they want us to solve how many mLs of supply to give per dose. So our supply comes 50%. And from Math 4, you know that 50% equals 50 grams per 100 mLs. So we'll use that as our conversion factor since it is an equality. Let's check out our units and crunch the numbers. So for the infant, we'll give them 0.25 mLs of the supply. In this case, the supply is 50%. Next, we have Clarke's rule. Clarke's rule is for children. Children are between the ages of 1 and 12. And of course, if they've entered puberty, you may treat them as an adult, or take a look at their body size. If they're in a larger 12-year-old and their body's the size of an adult, you may want to treat them as an adult in that case. Take their weight in pounds. This is one of the rare times we actually will use weight in pounds. Divided by 150, and then you multiply by the adult dose. Pounds over 150 times the adult dose will be the child's dose. All right, let's take a look at this example. We're going to have to figure out how much supply to give. How many tablets of supply is required per dose for a child that weighs 27 kilos, and the standard adult dose is 50 milligrams. Supply comes 10. So this equation needs pounds. So the first step probably is to convert those kilos into pounds. So 2.2. Now that we're in pounds, we'll divide by 150 and multiply by the supply. In this case, the supply is 50 milligrams per tab. Or sorry, the adult dose is 50 milligrams per dose, and the supply is 10 milligrams per tab. So in the end, you'll need 2 tabs. Young's rule. So Clarke's rule uses weight. Young's rule is going to use age. In this case, the age needs to be in years. So all you do is take the child's age, put it over their age plus 12 times the adult dose. So make sure you do whatever's in the denominator first. Clarke's rule, Young's rule, both are for children, about 1 through 12 years of age. So what if you're given just the weight information? Then you'll use Clarke's rule. If you're just given the age information, you'll use Young's rule. However, if you're given both age and weight information, you're going to have to solve for both, use both equations, Clarke's and Young's, and then give the child the lower dose, whichever amount is lower. Okay, today is January 15, 2018. We have a child that was born December. So let's use Clarke's rule first, 29 kilos. So you got to convert that to lbs. Divide it by 150 and then times the adult dose. So I'll give you guys a moment to punch that in. So make sure you change kilos to pounds by multiplying by 2.2. Right, so you should end up with about 42.5 milligrams. Next, we got to find the age. So this child is a little bit over 7 years old. So for Young's rule, it's 7 over 7 plus 12 times the adult dose, in this case 100 milligrams. You'd get 36.8 milligrams for Young's rule. So in this case, you have to do both, and the amount you're going to give is 36.8, the lower amount. AWP pricing. AWP stands for average wholesale price, and the average wholesale price is published in the drugs topic red books. And if you're ever looking for any therapeutic equivalence ratings, like brand and generic equivalents, that's a chapter within the red book. So these are published prices, and it's used to figure out the actual retail cost. And this is usually for brand name drugs. So packages, take the number of packages, multiply by the average wholesale price per package, multiply by the retail rate. This will include a markup. Add in the dispensing fee, and that will be your final cost of the prescription. Okay, packages. So normally we don't dispense an entire bulk bottle of medication. Usually it's a partial package. So for example, if you're dispensing 30 tablets from a 100 count bottle, you're not going to charge them for the full 100. You're just going to charge them for the fraction of that package. So in this case, they're going to use 30 out of 100, or 0.3 packages. Next, we have the average wholesale price per package. So just find that published in the red book or online. So in this case, our 100 count bottle has a cost, average wholesale cost of $225. That doesn't mean that's the cost to the pharmacy. That's what they can charge for it. The retail rate. So average wholesale price is 100% of the cost. So we're going to add in a markup. So that's going to be an additional above 100%. So in this case, let's say the markup was 30%. So the retail rate is average wholesale price, the base price, the whole 100% plus 30. So in this case, our retail rate will be 130%. And lastly, you just add in the dispensing fee. It's just an additional charge to cover a little bit of the supply. So it's anywhere from $1 up to maybe $5 in some places. For example, this prescription, the pharmacy charges $3.50 dispensing fee per prescription. All right, let's put it all together. Let's see what the entire cost of this prescription would be. So remember, we're not giving them 100 tablets. We're only going to give them 30. So we're dispensing 30. Average wholesale price for 100 is $225. We have a markup of 30%, dispensing fee of $350. So let's put it all together. So packages, we're using 30 tablets out of 100 times the average wholesale price times the retail rate. Make sure you do all your multiplication first before you add in the dispensing fee, 3.5. So for this example, the cost of this drug, the retail cost would be $91.25. The patient would then usually pay a copay, I don't know, maybe $10. And then the balance is billed to the insurance company. Okay, let's try this example. So the first thing is to find packages. So it's 90 out of 1,000 this time. Multiply by the average wholesale price. In this case, $4.75. The retail rate, well, the markup is 45%. So the retail rate would be 145%. Dispensing fee of $225. So let's set it up. So the quantity we're using, packages, we're going to use 90 out of 1,000. The cost is $4.75. The retail rate is 145%. So make sure you do all your multiplication before you add in the dispensing fee. So the retail cost of this prescription will be $64. All right, everybody. You made it, but that's not the end. There's plenty more of problems out there, different types. This is a good start for anybody beginning in pharmacy. So that's the end of this series of presentation, but look out for more. I'll be doing a lot of the math homeworks and assignments, making videos of those as well, answering the common questions. So those should be coming up soon. Once again, thank you for joining us. And if it's your first time, go back in, subscribe. There's going to be plenty of videos getting you ready for the PTCB exam. Once you go Fong, you never go wrong.